uses grocery coupons when shopping, and X represents the cost of groceries that she's going to buy before coupons, with Y representing the amount of money she saves by using coupons. We have distributions for X and Y, and it can be found that the mean of the X's is 86, the mean for Y is 13.5. We want to know what is the standard deviation of how much Sherry spends, and this is going to be a total amount of spending. If we think about the fact that she has a total amount of money before coupons and then the cost of savings with coupons, what we're really interested in is a function of X and Y that is X minus Y. If we want to find the standard deviation of X minus Y, we want to first find the variances separately. So we want the variance of X and the variance of Y separately. We have our means, so the last thing we need to do to get our variances is to find the sum of our variables squared times their probabilities. So for the x's, we'll have 50 squared times 0.1 plus 70 squared times 0.3 plus 100 squared times 0.6. And this will give us 7720. So if we want the variance for the x's, we take 7720 minus our mean of 86 squared, and we get 324. We'll do the same thing for the y's. So we will have 10 squared times 0.5 plus 15 squared times 0.3 plus 20 squared times 0.2, and that will give you 197.5. So if we want the variance for the y's, we will take our 197.5 and subtract the mean we're given of 13.5 squared, and we get 15.25. Now we have a rule that says if you want the variance for a combination that's written as x minus y, you take the variance of the x's plus the variance of the y's, and this should be a plus, not a minus. We do this in terms of variances first because that's how the rules are given, and then we'll get the standard deviation at the end by taking the square root. So the variance of x minus y will add the two variances that we got separately, and these are 324 and 15.25. So the variance that we get for x minus y is 339.25. So now if we want the standard deviation for x minus y, we take the square root of this, and what we get if we put it in terms of dollars is $18.42 for the standard deviation of x minus y, which represents the amount of money Sherry spends.